Again, welcome to Java Programming 1. In this lecture, we are going to discuss about using classes and also objects. This is our Unit 3 Part 2 lectures. In Part 1 lectures, we studied about a minimum of 3 different classes, built-in classes, and the math class, and also we discussed about the random class, etc. So in this section, we are going to learn two things: the Java types, enumerated types, and also the wrapper classes. Enumerated types are normally a type that the user can create. So I can create a data type as a student, and I'm going to specify what values I can put in it. Say in my class, I have 4 students. So the possible assigned values for the data type student to be 4 different names, such as Charles, Williams, James, and Morris. So enumerated types are normally the types that we create. And also we're going to discuss about wrapper classes. So first, we are going to discuss about how we can use a class name normal format to format an output. So for example, if I have an output as let's say currency or a decimal number, I can use either a decimal format class, which make it possible for me to specify the pattern of my decimal value, how many decimal places I want, etc. And in order to use the normal format also, for example, if I want to format a value as a currency, I can use the normal format class. So these two type of classes, again, a built-in class, but these two classes, they are not in a java.lang. We talk about a java.language package. Automatically it's imported into our Java program. So we don't need to import it. But with normal format and decimal format, we have to import the package test. So java.test package. So in order to use the decimal format class or the normal format class, I need to import the package java.test. And we will see an example. So as we said, the normal format class contains, also it's a static methods. So the methods that we have in the normal format class is a static methods means we don't need an object in order to call those methods. So those two methods are get currency instance. I'll use this method to format an output in currency, like $20, 2 cents. And the cent will be 2 decimal places. Also, I can format a value as a percentage, 30%, 100%, using the get percent instance. But again, these two methods are called a static method. They are static method. Why? In order to call these two methods, I don't need to create an object. So these two, again, methods belongs to the normal format class. Again, in order to use the normal format class, I also need to import the java.test package. So we're going to see an example in the next page. So here we can see the first thing, we import the java.test. If I like, I will import the java.text dot asterisk just to get all the methods. But here we want to use only the number format. So we say java.test.number format. Again, if I want to import all the methods in java.test package, I will just include the asterisks as we did in scanner utility package. Here also, I want to import only scanner. So in this program here, we say we're going to demonstrate the use of the number format class to format output. That's it. So we import the two packages, scanner. The reason why we import the scanner class, we are going to ask the user to enter an input. And the reason why we import number format, because we want to format our output, either as a percentage or currency. So here, calculate the final price of a purchase item using the values entered by the user. So this program will ask a user to enter some items, price, and we know the tax rate is 6%. And we're going to, again, print out the final total price. So the first thing we do is declare the constant variable name tax rate. Tax rate. In Java, we know the final keyword, we use it for, again, creating a constant variable. The type is double, so we initialize it with a double value. Again, anytime we create a constant variable, we always have to initialize it. Next, we have a variable named quantity. The data type is int. We also have another 4 different variables here. Their data type is double. So we declare all in one line. We have the subtotal, task, total cost, and unit price. Now we want to ask the user to enter an input. So we create our scanner object, which is called a scan. So scanner scan equal to new scanner system.in. System.in means we want to use the keyboard to get our input. So now we create our normal format object, name format 1 and format 2. And the first one is for currency. The second one is for percentage. So again, normal format 1 equal to normal format dot get currency. Also normal format FMT2, which is the format 2, is the normal format dot get percent instance. So here we ask the user to enter the quantity. We already created our scan object, the scanner object, which we call the scan. So we say scan.nestInt. We are using nestInt because quantity data type is int. Then next we ask the user to enter the unit price. This time we are using nest double because the unit price is declared as a double. So scan.nest double. So now we know the quantity the user buy and the price for each item. So we multiply the quantity times the unit price, and that will give us the subtotal. The reason why it's subtotal, we also have to pay a tax. So next we find the tax, the subtotal times 0.06. So tax rate is 6%. The answer we get as a tax, we add it to the subtotal, and that will give us the total cost. So finally, again, this is input, processing, and output. We get our input, which is, again, the quantity of item we are buying, the unit price. Then we find the tax rate. Then we multiply the tax amount with the subtotal of the quantity times the unit price. So we know the total price. Now we want to print the output. So here we say system.out.println. This is a string subtotal, so double quotation plus. Now, the reason why we have a plus here, because we're going to get the value of want to print the value of the subtotal. By here, we had a subtotal using format method and FMT1, which is the object. So this means we are making our subtotal as what? As a currency type, because when you look FMT1, it's a get currency instance. So we are changing the type to, again, currency. Then next we print the tax rate. The tax rate, of course, tax is in percentage. So we are using the FMT2, which is get percent instance. So our output here will be in percentage. And the total value should be currency. So the total, we remember it was the tax times the subtotal. And we use the FMT1. FMT1 is always for currency type. and FMT2 will be for percent type. So this is how the output will look like. We ask the user to enter quantity, the user enter 5, enter the unit price 3.87. We can see that even give us the currency. The get currency instant give us the $sign. Then the tax rate we say is percent, so you give us 6%. 0.06 will give us 6%. So when we had the tax rate, the tax with the subtotal, we get the total. The total also is in dollar. The goal here again is to understand how we can use both the number format class and also the decimal format. The decimal is the same process. So if I'm using decimal, then I'll put a decimal format here. And they use the same. But again, the type will be different. Get currency instance and get percent instance is for number format class. So now let's say example of formatting output using the decimal format. So the decimal format, the same thing, we have to import the text package. This time we are importing the decimal format. We are going to ask the user to enter input, so we're using the scanner class also. So this program will calculate the area and also the circumference of a circle given its radius. So we declare variable radius and also 2 variables for the area and circumferences. Since we are going to ask the user to enter the radius, we again create our scan object, which is called scan again. So we can say the scan.nextInt for the user to enter the radius. When user enter the radius finish, we find the area. The area will be what? Pi times radius square. But this time we want to use the math class. So we can use math.pi. The pi should be uppercase. So math.pi, this will give me the power value, times math.pow, which is the power. The power always take 2 arguments. The first will be the base, the second will be the exponent. So this is like radius square. Now circumference also will be 2 pi, so math.pi times the radius. So now we have to create our decimal format object. So the object name is FMT. Here we have to show decimal format doesn't have a what we call it, a method like get currency or does it. So we have to show the argument to be the format, how many decimal places we want. So here we want 3 decimal places, so 0.3 pound sign. So next, I'm going to print my output. The circle area is, we know is the area, but we want to make the area 3 decimal places, use the number format. So we have to look for the object, FMT. So FMT.format and the attribute. Circumference also the same thing. We want to print 3 decimal places, so we have FMT.format again. So when we run this program, you can see that we have here the circle, the highest exponent decimal place you have is only 2 decimal. So you give us 78.54. Here we get other 3, 31.416. The radius center was 5. So next we go through what is an enumerated types. This we said again is the user defined type. So Java allows you to define an enumerated type, which can then be used to declare variables. So it's like user defined variable type. So we say an enumerated type declaration lists all the possible values for a variable of a type. So when I declare enumerated type, let's say season, I will list all the value that it will be winter, fall, spring, and summer. So the values are identified of your own choosing. So I can choose any of these 4 seasons to represent a variable type season. So that's what we have here. We want to have a type named season. So this is my variable type, user defined. We always use the keyword enum or enum, enum. Then the type name. Then open a curly brace, all the possible values or the entries that we can enter into the variable. So now if I declare a variable, let's say the type is season and the name is name, then I can assign any of these four, only these four values. As far as the type is season, this is the only four items that I can assign to it. So here, example, we declare variable name type, and the type also is a season. So season type, time. So this means our data type is season, and the name of the variable is time. Now, the only thing, since the type is season, the only items that I can assign to time is these four items here. We have to, again, define our type first before we use it. So here you can see that time equal to season.fall. And when you look, we should have fall in here, fall. So we can use the fall, summer, spring, or winter. And ordinal values are in values that they are in order. We can do the same thing in enumerated type. So here we say internally, each value of an enumerated type is stored as integer called its ordinal value. The first value in an enumerated type has an ordinal value of 0. The second is 1, and so on. So here we say the declaration of an enumerated type is a special type of class, and each variable of that type is an object. It's not a primitive type, it's a class type, Enum. So let's see the example, ice cream. So here we have a program to demonstrate how to use them, enumerated types. So we have our main class name is ice cream, so the file name will be ice cream.java. So you see we have the keyword enum. The type name is flavor, and these are the possible names that we can assign to any variable that the type is flavor. So here we have vanilla, chocolate, strawberry, fruit, apple, etc. So here we are going to create our variable and then use the flavor or the enum type. So you can see we have a flavor, con1, con2, con3. So our variable is con1, con2, con3. The type, the data type is flavor, which is the enum type. So next, I want to assign a name or item to con1 and con2 and con3. So I will say con1 equal to, always we start with the enum type name first. So we say flavor dot Rocky Road. So Rocky Road should be one of the values here, which is right here, Rocky Road. So always flavor dot Rocky Road or flavor dot cooking dough chocolate. So the next one, con2 flavor dot chocolate. And then we print our output out. Next, we have con2 name. We print the name. And also we assign con1 to con3. So whatever value or the flavor of con1, we assign it con3. Then we print it also. The goal here is how to use the enum. So let's go back again. First thing we do is to declare the type first, and using the keyword enum, the name of the type, then curly brace, open and close, and have all the possible values that you can assign to a variable that you are going to create using the flavor. And that's what we have here, flavor.rocky road, con1, flavor.chocolate, con2. and to the type is flavor, which is the Enum type. So we can assign any of these values to it. And the next going is just to print the output. So the last section is what is a wrapper class. Wrapper class also is in the java.lang package. So java.lang package contains a wrapper classes that correspond to each primitive type. So a primitive byte, the wrapper class will be byte also, but the names are the same, but they start with uppercase, except integer, which is int, but here we use the full word integer. Most important, you can see that the names of the wrapper, always class names start with uppercase letter by convention. But this is a built-in wrapper class, so if we want to use this, we have to have it as it is here, the name. So the following declaration create an integer object. This time it's not integer, it's no more a primitive data type because we are using a class, which we call the wrapper classes. So the integer object, which represent the integer 40 as an object now. So you see, instead of saying int age, I'm using integer, age equal to new integer 40. So this is the constructor, and we are initializing age to 40. So this is now an object. Actually, anytime we use the new keyword, it's like dynamically allocating a memory space for an object, not for a primitive type. So an object of a wrapper class can be used in any situation where a primitive value will not again suffice. So for example, some objects serve as a containers of other objects. Primitive values could not be stored in such a containers, but wrapper object could be, because it's a class, it's an object. So wrapper classes also contain a static methods. Actually, that's why it's a class. Every class consists of the instant data and also a method, which is the behavior, define the behavior of the class. So one of the method is parseInt. So if I have integer dot parseInt str, what I'm trying to do here is that I'm trying to change the data type of integer as an object class to a primitive type. So here, say for example, the integer class contains a method to convert an integer store in a string to an int value. So I'll use integer dot parseInt. This is the method that will convert it to int. And this str again is where the data is. So they often contain useful constants as well. And here we say, for example, that integer class contains mean value and mass value, which hold the smallest and largest int value. And this is example. Auto-boxing is what we call the automatic convention or automatic convention of primitive value to its corresponding wrapper object. So if I have int num equal to 42, this is a primitive type. We can convert it to, again, a wrapper class and object. So automatic conversion of primitive value to corresponding wrapper object. So the assignment creates the appropriate integer object. Also, the reversing of it, which means I'm going from wrapper class to primitive instead of primitive to wrapper class, is called unboxing. Unboxing. This also occurs automatically as needed. So here we say again, auto-boxing is the automatic conversion of a primitive value to a corresponding wrapper object. And also assignment creates the appropriate integer objects. So we have a quick check here. Are the following assignment valid? We should explain. Here we say double value equal to 15.75. Remember, double with the uppercase D means an object wrapper. So here we say yes. Why? Because the double literal is auto-boxing into a double object automatically. And also this is also possible because the char is an object. It's unboxed before the assignment. So here it's like, here we are changing from int, which is a primitive type, to again a wrapper class, which is an object double. And here we're going the opposite, from the character class to primitive. So again, this will be the conclusion of our lectures. Again, these lectures we learned about user-defined type using the Enum or enumerated type. Also, we discussed about the wrapper class. Also, most important, how do we format a data using classes? And we also discuss about the number format and also decimal format classes. And we have some examples. So again, hopefully soon we're going to have our Java lab videos posted. So we will see some programs on this topic also, and lab work. Thank you. Bye.